This is 4.2 note session for Mr. Mack's algebra class. Our goal today is to graph linear equations in a coordinate plane. You have 5 vocabulary terms that need to be defined in your notes. Please pause the video and take care of this responsibility right now. Once again, please pause the video before you move on. Sometimes the best way to understand mathematic vocabulary terms is to see them in action. So, a solution of an equation in 2 variables is quite simply an ordered pair solution that fits within a function or an equation. For example, as we look at this function below, we see that there are several points that lie on the line. One of those points is 1, 3. This is a solution in 2 variables to the following equation. Next, when you are asked to graph an equation, what you're doing is you're actually drawing a line that indicates all possible solutions of that particular equation. So this entire line represents every possible solution. Now, the solutions do not fit on just this coordinate plane. Therefore, we have to use arrows that go in both directions that show the general pattern of the function. Finally, this equation is linear because there is no curve in the line, and it's also a function because no 2 different x values have the same y value. So one way that students have the best understanding of whether a line is a function or not is by doing a vertical line test, where you take a ruler or a straight edge and you pass it through the graphed function. If that line only hits one point at any given point in time, then your line represents a function. If for some reason that vertical line touches more than one point at any particular point in time, then therefore that line represents an equation that is not a function. In this situation, as you can see, we have a function. Now, the first type of problem you will encounter in 4.2 is when you're asked to graph an equation, but you're not given a domain, like in section 1. Well, the first thing that we need to do is we need to make sure that we solve the equation for y. We are doing this because we are making sure that y is a function of x. The next step is to make a table of values. But we're not given values like in section 1, so therefore we have to create our own for x. When you're not sure what a pattern is, and you're not given any restrictions, the 4 values or 5 values that I would recommend are -2, -1, 1, and 2, if you're looking for 4 values, or 5 values, -2, -1, 0, 1, and 2. Once you decided which points or which coordinates you would like to put in for x, then you can solve for y. As you can see, when x equals -2, y equals 6 in this particular equation. Once you've found all those values, you'll then place those all in ordered pairs and then plot your points. Once you've plotted the points, you should connect the points by drawing a line through them. Use arrows to indicate that the graph goes on without end. This is because we do not have a restriction to our domain, and therefore the domain is all real numbers for x. The second type of problem that you will encounter in 4.2 is when you're asked to graph an equation, but there is only one variable in that equation. For example, A has y equals -3, and B asks you to graph x equals 2. In this situation, for A, regardless of the value of x, the value of y is always -3. The graph of y equals -3 is a horizontal line 3 units below the x-axis. Notice how this line includes y values that are only -3, regardless of what x equals. Now moving on to example B. regardless of the y value, the value of x is always 2. The graph of x equals 2 is a vertical line, 2 units to the right of the y-axis. Notice that on this graph, x always equals 2, regardless of what y equals. Before we begin working on the checkpoint, I'd like to direct your attention to the bottom of this page's notes. You'll find this table. Notice that when we graph a function, I shouldn't say a function, when we graph an equation where y equals a value, the line will always be horizontal. And that line will pass through 0, and whatever that value is for y. And conversely, the graph of x equals a, or any value, is always going to be a vertical line. And the line of graph x equals a will pass through the point of a, whatever value a is, 0. Now, please pause this video and begin working on questions 1 through 4 for the checkpoint. Here are the questions, or the answers for questions 1 through 4 on your checkpoint. Notice that 2 and 4 are either vertical or horizontal because we have only one variable in these equations. Let's look a little closer at Chapter 4, Section 2, checkpoint question number 3, where we're asked to graph y equals negative 4x plus 1. The first thing that we should do is create a table of values. Once again, I've chosen 5 points here, and my favorite 5 points to use if I don't know a pattern or there isn't a restriction are negative 2, negative 1, 0, 1, and 2. Once I've found the values for each of my y's, once I know my x's, I can create ordered pairs. Once again, because a domain was not given, it is understood that the domain includes all real numbers with no restrictions. Now that I have all of my ordered pairs, I can then place those on a coordinate plane. Once I've placed all of my points on the coordinate plane, I can draw a line that passes through each and every single one of them. This line represents every known or possible solution to this equation. And this is a function because, according to the vertical line test, it only has one value for each x value. Now, the next type of problem that you'll encounter in 4.2 is you'll be asked to graph the function when you're given a restriction in the domain. And once you've done that, you'll be asked to identify the range of a function. Well, the first thing that we need to do is the same thing as we have for all of our functions when we're asked to graph. We make a table. But we need to be more strategic in the values that we choose for x now. Because the domain is equal to x that is greater than or equal to 0, that means that our value should include 0 and then any value greater than 0. So in this situation, I chose 0, 1, 2, 3, and 4. And when x is 0, y equals 2. When x is 1, y equals 4, and so on and so forth. Once we have gotten all of our ordered pairs, we can then place these points on a graph. Notice that when I draw my line, I do not create a full line. Instead, I connect the points with a ray because the domain is restricted. Afterwards, I can identify the range. From the graph, you can see that all points have a y-coordinate of 2 or more. See right here at the end point, it's 2 for y, and then y only gets larger from that point on. Therefore, the range of the function is y is greater than or equal to 2. Also, what I'd like you to notice here is that my endpoint for the ray is solid. When you have a less than or greater than and equal to inequality, you should always fill in the endpoint. When you have a less than or a greater than inequality symbol, you should leave that circle hollow. And now it's your turn. Graph the function y equals negative x plus 4 with a domain restriction of x is greater than or equal to 0. Then identify the range of the function. Please make sure you pause this video at this time, so that therefore you can attempt this problem without seeing the answer. And here's the moment of truth. Did you get it correct? This is what your graph should look like. The range is y is less than or equal to 4. Also notice the explanation below. You can now begin on your Q and review questions on page 215, the guided practice problems numbers 1, 3, and 4.